Is it 7.5
Throw units into it, yes.
meters per second?
Did anybody get 9? The most common mistake that students make is they add them all up. I assume you got 45, and then divide it by 5. How many numbers are there? 6. 1, 2, 3, 4, 5, 6. There are 6 numbers that you're adding together.
I'm upset because as soon as I got 32 and read like with like remainder of 5 or something like that. And as soon as I'm thinking like, oh, I wasn't supposed to add a 0.
No, you definitely supposed to add in the 0.
Well, so I got like 32, I don't know. I was supposed to do that. But,
You add them all up, I'm not sure what if you add them all up, you should have gotten 45.
okay, well, I'll add it again.
And by the way, I'd recommend you bring a calculator you know how to use to the test when it comes time. And we do have extras if you need to borrow one for a test. I guess we already had a quiz, so you've gone through this before. Now, I'm going to change the problem. All right, so, well, actually, we'll do that part in this moment. So it's 7.5 meters per second is the average. So going over here and looking at the math, we're going to do this slightly differently in just a moment. But going over here, this becomes 7.5 is equal to my displacement divided by my time. That's the math problem right there. And so my displacement is what?
$37.5. Meters per second.
Someone help me out.
Meters per second?
Somebody help her out.
Square.
No, that's what he said.
Is it just meters?
Just meters. It's where are you relative to where you started? Well, you're 37.5 meters away.
Mr. I fumbled the ball, I'm sorry, I can't think of. My son didn't get picked up from school, that's what's going on. I was just a little nervous, so what y'all was just talking about? I was left at 45.
You said you finally got 45?
No, I said I was left here because I had got a text about my boy, I don't really know what's going on.
Okay.
What y'all was talking about?
In terms of finding average velocity, you add up the numbers and divide it by 6 to get 7.5. That's the average velocity. Then we just plugged into this equation that 7.5 is equal to the displacement, which is what I'm trying to find, divided by the time, 5. So it's 7.5 is equal to something over 5. Multiply both sides by 5, and you get that.
Okay. And that's gonna be.
And that's the answer.
Huh?
That's the answer.
Okay.
That's what you missed. All right. Let's take a look at average velocity a slightly different way. I need more time here. So let's do 12 meters per second squared. Oh wait, no. How would be 3 meters per second squared for 12 seconds? And instead of starting it at rest, it starts at negative 10 meters per second. So it starts out going in the negative direction. So if up is negative, then it's possible the ball was thrown up into the air on some strange planet which has an acceleration due to gravity of 3 meters per second squared. I want to do it the chart method because there's a point I'm getting to there. So I have time in seconds, I have velocity in meters per second. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Initial velocity is negative 10 meters per second because that's what's in the problem. So it starts out at negative 10. And how much is it going to change every single time? Each second, how much is the velocity going to change?
10 seconds?
3.
Yeah. Each second, how much will it change? That's what the acceleration is telling us.
Okay.
So after 1 second, what is the velocity?
-7.
What is the speed? Was I expect people to get thrown on that one?
Is it -7?
No.
Is it still 3 meters per second?
No. Velocity is -7. What is the relationship between velocity and speed?
One of them needs a direction.
So velocity needs the direction,
Speed doesn't care about direction?
right? Therefore, what's the speed at 1 second?
A +7?
Yes, meters per second. Yeah, the negative sign is a directional thing. That means it's going in the negative direction. So the speed is just the absolute value of that. All right, so after 2 seconds, I better do something, otherwise I can get way off here. All right, so that's at 1 second, 2 seconds,
-4,
keep going.
-1, 2, 5, 8, 13, 18,
11, it's 11,
oh, 11.
You suddenly jumped to adding 5.
14, 17,
21, 24,
it's 20, not 21,
oh.
23, 26.
Okay. Any mistakes would have been noticed at some point. All right. Now the question is, what is the average velocity? So if you, enough people crank through that. And the answer should be an integer, so if you were doing this by hand, it should come out nicely.
Is it 26?
It should not be 26. Did you add them up and then divide?
6.
I got 8.
Yeah,
I got
it's 8. What was the sum did you get?
104.
You had 104 when you added them all up? Oh, we got the negatives in there. So my average velocity, 8 meters per second. What's the displacement?
negative 8 meters per second?
No.
No?
Alright, so displacement again is how far am I from where I started? So another way of looking at that, if you drive on average 50 miles per hour for 3 hours, 50 miles per hour for 3 hours, how far did you go?
Positive 50, or, you go 50 miles?
50 miles per hour
Yeah.
for 3 hours.
150?
Oh, right.
Yes. So you just multiply them. So it's a similar type thing. On average, you're going 8 meters per second for 12 seconds.
So 8 times 12.
Yes. So my displacement,
96.
all right, 96 meters. That's my displacement. So I end up on the positive side of where I started, which makes sense because I ended up at positive 26 instead of at negative 10. Or started at a negative 10, went up to 26, which is faster than I started. All right, so adding up the 13 numbers, you might enjoy it. I would find that a nuisance. I would be nice if there was a shorter way of doing it. So let's do a shorter way.
Mister, no, I did not calculate the 0 again, so I did not divide by 13 when I
Oh.
got the 104. So that is wrong.
Well, there's no 0 there. You're adding up these numbers. There's no 0 there, so.
Well, you said added up the 13 numbers.
Yeah, you added up only 12 numbers?
Yeah, I just said that.
104, so what other people got?
Yeah, I got 104 too, that's right.
And then divide by 13.
No, like I said, I didn't divide by 13, I divided by 12.
Twelve does not go into that evenly.
That's why I said like 8.6 or. Yeah, I got 104 divided by 12, and I got 8.6 and a couple others.
Oh. Yeah, that 0.6 and stuff, you can't just drop off because you don't like them. So 104 divided by 13 is 8 even. All right, so we did it by every second, and there are two criteria that, in order for this to work, of adding them up and then dividing by how many you have, there's two things that need to be true. One, acceleration needs to be constant, which it is. Two, the time increments need to be the same. 1 second, 1 second, 1 second, 1 second. I'm going up by 1 second every single time. But there's nothing special about 1 second in particular. I could go up every 2 seconds. So if I get rid of this one and this one, getting rid of all the odd ones. Now let's add them up. So I got negative 10, then negative 14, negative 12, negative 4, 10, 30, 56. And then divide by 1, 2, 3, 4, 5, 6, 7, 56. 7 goes into 56, 8 times. Wow, what a coincidence. But there's nothing special about every 2 seconds, so why not every 4 seconds? Let's just do it that way then. Let's get rid of that one, and that one. So now we're doing 4 second increments. And you add them up, I got negative 10, negative 8, 6, 32. 32 divided by 4.
8.
So what's so special about 4 seconds? Why not every 12 seconds? I add those two up, I get 16, I divide by 2, 8. So in the constant acceleration problems, all I really need to do is just look at the first and last velocities, add them together and divide by 2. So in that first problem, when it started at rest and ended up going 15 meters per second, the average velocity was going to be 7.5, because that's the average of 0 and 15. All right, so I think we are ready to get more complicated. Any questions before I erase that? Or any questions after I erase that? ball, initial velocity, make it 30 meters per second. Acceleration, uniform. -5 meters per second squared. And let's let the problem go for 9 seconds. Be final. Average. Displacement. Distance. Before that. Time, stop. Distance. And then average speed. All right, that's pretty much the order in which we're gonna do this. Now, if I give you a multi-step problem like this, let's say it's a task, and you have, I guess, 6 parts to it. Depending on how your mind is working at that moment, you're not necessarily gonna do it in the same order that I would do it. So if you could find this first, before you find this, hey, more power to you. Feel free to answer this one first, and then just draw an arrow saying that you got this based upon this number. You don't have to do it in the order in which I present it. It's just that I'm taking a guess. This is the way I would do it in a particular order, and just taking a guess at how you would do it. All right, so we could do the chart method, and there's nothing wrong with that. It's 9 seconds, so that's doable. Or we could do the more equation-oriented method. Let's do it both ways. Let's start out with the chart. So this is 30. 1, 2. So after 1 second, what's my velocity?
25.
And then so on. All right, and the dotted line has no meaning other than I'm just trying to keep it straight since I don't have a line board. So we have an answer of -15 meters per second. Dramatic pause for questions.
Yeah, just real quick.
Yeah.
What's the little thing beside the V on top?
The little thing besides the V on top.
Right
Here or over there?
No, yeah, right there. The little small thing beside the V.
Subscript.
That?
Yeah.
That's an F
F, alright,
for final.
there we go, thank you.
So what's all of that, is that T, that
Oh, okay,
T
that makes a
step?
lot more sense.
That's T stop. This is the time that the object stops.
Oh, okay.
I guess I should explicitly write. A one-dimensional problem. Well, it's just moving along the line. We're not dealing with two-dimensional problems where it's traveling through space. Or curving through space.
What does that V at the very bottom say? Subscript and that?
The AVG average.
Oh, okay. I just couldn't tell.
Yeah, I was right that you were fine with the AVG, but not the.
I was picking up
as soon as it gets more than one letter, but I didn't know what the one letter was. I figured a minute, I just assumed it was average on the bottom.
Yep, it was. Alright, any other questions? Either about what I've written, about my handwriting, or about the actual problem?
Yeah, why did you just put 15 right there, I missed it?
Negative 15?
Yeah,
The question is, what was the final velocity, and by doing the chart, we started with our initial velocity,
yeah,
which was given in the problem.
okay,
The acceleration was negative 5 meters per second squared, which means every second that passed by, the velocity changed by negative 5,
oh, okay.
and just working our way down, got negative 15 at the end.
Sure.
So, what, doing the next one?
No, no, no. Your chart.
Okay. Yeah, again, my hearing is not great, masks don't help. So, and I know students are often feeling very shy about saying their answers loudly, but we're all gonna make plenty of mistakes in here. It'd be cool if we just proudly give answers loudly enough for me to hear. All right, so let's take a look at it from the equation point of view. That's the acceleration, is the change in velocity over time, change in time. So I have negative 5 is equal to my V final minus 30 divided by 9. You bring the 9 over, again, when you're solving for an unknown, you start peeling away the layers of the onion. 9 is the one on the outside, so let's get rid of that first. We undo dividing by 9 by multiplying by 9. So 9, so I get negative 45 is equal to VF minus 30. And then